Namaskar. We are back with the new chapter or edition of Career Corner. In every episode of Career Corner, you meet one stalwart of one particular field, a domain, and the expert speaks about his or her domain, how has he or she evolved in that, what are the various aspects of that particular field, how is the society benefited by that, and how the education of that particular domain evolving over time, and what are the futuristic outlooks of that particular domain. Specifically, we bring in experts from various departments, schools, and disciplines of Adamus University, the university known to be the best private university in Eastern and Northeastern India, thanks to ranking by various media organizations like ABP Anando, India Ahead, Z News, and many more. Today, in this episode, we talk about physics. Physics, a very well-known domain or aspect or specialization within natural sciences. Yes, at the higher level of living existence and knowledge, there is no differentiation between one discipline of science and the other. Natural sciences together present the reality of the world, the natural reality of civilization or of the world. But then, for understanding's sake, we focus on various aspects. Physics on the physical natural sciences, physical environment, chemistry on chemical natural sciences, life sciences or biology focusing on life and its existence, and so on and so forth, because each of these have further specializations, niche specializations within them. Physics as a discipline of learning, physics as a discipline of research have evolved from the times of Newton, when gravitation was discovered by Newton, observing the fall of an apple, and we know that story. From Newton to Einstein, when he talked about E is equal to mc square and defined the characteristics of energy, to the current recent Nobel Prize winners in physics. Say, for example, Andrew Gein or Nobel Salev, and many others. This entire gamut of subject of physics have evolved over time. Today, we'll know about how it has evolved, how it has made an impact on human life, on society, how it is a specialized domain of learning, how at a higher level, research of physics is also bringing in futuristic trends and outlooks. With us today, Professor Moumita Dey, the head of the Department of Physics in Adamus University School of Basic and Applied Sciences. Thank you, madam, for your presence today. Welcome to the show.
Thank you very much, sir.
Madam Moumita, you can begin by speaking about your personal journey as a physicist. What have you studied? How have you done your research? What were your themes? Where did you do all that? What were your revelations in life, or what should I say, your sort of realizations in life as a physicist? Why did you select physics as your specialization?
Yes,
all these, if you could speak at length.
Yes, sir. Thank you very much, sir, for your kind introduction. Hello, everyone. So, from the very beginning of my school life, say from class 8, I was initially very much inclined towards studying those physical science discipline that we had. And it always intrigues me, it always makes me curious that how things work, how am I being able to sit in this chair, how if I drop this pen it falls on the table. So it was a very intriguing thing. And then when I started in my class 11-12, then also I find physics very much interesting. So I had decided by then that I will become a physicist. And then I started my graduation from Calcutta University, post-graduation from University of Calcutta, and then I did my post-MSc associateship and doctoral research from Shaha Institute of Nuclear Physics, Kolkata. Actually, my specialization was theoretical physics. It is more precisely, it is theoretical condensed matter physics. In my research area, we all know about nanotechnology. People today talk about nanotechnology a lot. And in my research area, I had focused on spintronics, that how a completely neglected degree of freedom of electrons, which is called the spin, can brought about a lot of changes in electronics, and later I'll talk about it in details. So that was my research domain. I had published more than 20 articles in international SCI journals, and still now the journey is on. And then I had joined here as an assistant professor, and now I'm leading this department of physics.
Great. Is this your first academic job?
Yes, sir.
Okay.
Just after being completed my PhD. Yeah.
Spintronics, that's very interesting, something specialized domain within physics.
Yes.
So if you could talk about the various specialized domains of physics. So what could be the various, someone who has studied MSc in physics goes into some specialized domain for further work, further research.
Yes.
If you could speak on what these domains are.
Yes, there are very lot of, actually physics is a very fundamental subject, and from physics you can go to different disciplines, like from different areas of foundational subjects, from different areas of application of physics. In our MSc programs, we also have that kind of specializations. Like first is high energy physics. We all know about that. People are quite romantic about this astrophysics and cosmology thing, and they're interested about these things, how astronomical things are working outside this space. Right. And then we have condensed matter physics, which was initially named as solid state physics, and then after inclusion of liquid crystals and everything, now we can call this discipline as condensed matter physics. Then we have specializations like biomedical instrumentation and medical physics, which I think is the need of the hour. It is a very important discipline, and physics has a great impact on medical science. And then there are specializations like applied electronics, non-linear dynamics, which has a great impact on data science and weather forecasting, weather prediction models. Then there are specializations like fiber optics and laser. So there are various multiple disciplines from which a student can pursue and take on his dream.
Great. So for those who thought that physics itself is a specialization at school level, you think so. I understand that. Physics, chemistry, biology, that way we think. But when you enter into physics, you understand there are 10, 12 different domains within that, and you finally choose one after having. That's the beauty of learning sciences. You used to start your journey in your school as just a sciences, a paper, a module, a subject called sciences. And from there, you move to physics, chemistry, maths. And from after BSc, and when you come into MSc, you move into further specialization. At PhD level, you might even get into further niche areas. So that's how a pyramid structure of education is built up. That's the right way of learning anything, not just sciences, not just natural sciences, but whether it's social sciences, communication sciences, or whichever, management sciences. It's good to learn from a broad base to a narrow apex, and the apex specializes on a niche area. Professor Moumita, thank you for that introduction to the subject and its various specialization areas. I understand physics has been there for ages, and from Newton to Einstein to Andergine and others, it has been there. So how is it relevant even today? And why do we call, I understand when students start their journey, they call it physics. It is supposed to be called with a broad word called physics. But how is it relevant even today's context in education and in society, if you could speak on that?
Yes, a very pertinent question. Yes, physics is not a very new name. We all have heard about it. And whenever it's not a new name like spintronics, as I said, or say geoinformatics or bioinformatics. This is there for centuries. And whenever I utter this name, physics, as Sir said, multiple names pop up in our mind, and you don't have to be a physicist to know those names. Like in 16th century, Galileo Galilei. In 17th century, Sir Isaac Newton. In 18th century, there were Michael Faraday, Ohms, just to name a few. In 19th century, there were Clerk Maxwell, Nikola Tesla, and then one of the brightest time in the history of physics, who were not there then. From Albert Einstein to Richard Feynman, from Paul Dirac to Erwin Schrödinger, from Minkowski to until very recently, Sir Stephen Hawking. And even if we think about our own country, we had stalwarts like Sir Jagadish Chandra Bose, Satyendranath Bose, Meghnad Saha, C.V. Raman, S. Chandrasekhar, Homi Jahangir Bhabha. So all these people, they have inspired us, they have amazed us to their out-of-the-box thinking, through their study, through their discovery. So now let me come back to you, sir, to your question. So after all these ages, all the centuries, and all these discoveries, why physics is still relevant? Why shall we study this subject or not? Why it is so indispensable? So my answer is that physics is the study of nature, and to be more precise, physics is the study of matter and energy and their interaction. So what are you seeing around us? It is matter. The light I am seeing, it's an energy. The sound I am hearing, it's an energy. The heat I am feeling, it's an energy. So it is either matter or energy. So if we need to understand the everyday natural phenomena around us, we must understand physics. And physics has a lot of I mean impact on the progress of society, and I'll talk about it later. But for the time being, let me just say that physics is the major driving force behind the development of any technology. And those technology has reshaped our lives. I mean, it is there in everywhere, like functioning of a small scale miniaturized nanoscale device to understanding of a large astronomical object. From application of nonlinear dynamics to weather prediction model to stock market prediction by using data science and statistical ideas. From using
data science and statistical also ideas can be a part of physics as well?
Yes, yes, of course.
Great. That's interesting.
Statistical mechanics is an integral part of physics, and
that's interesting.
Yes.
So there are three types of matter and there are various forms of energy. So these three types of matter and the various forms of energy, their interaction is the focus area of natural sciences, and how these interactions lead to various technology when applied. Yes, please continue. This application part is very interesting. Continue. How it is affecting the society or impacting on society.
Yes, it is there. I mean, to talk about that how physics has reshaped our lives. So let me ask you, sir, one question, that can you imagine a day of your life without your cell phone?
No, not
Probably
at all.
Not.
Not at all.
Can you imagine a day without your laptop or desktop or internet
not
connection?
Anymore. I mean, in these days in the
feel?
digital world, not anymore.
Yes, sure. So you will feel disconnected. You will feel that something is less, something isn't there. You will. We all feel that. In fact, forget about smartphones. Few days back we had Amphan, and probably one of the greatest storm our country, our state has ever seen. And due to the post effect of after effect of Amphan, in many areas there were 2, 3, 4 days even there were power cut, and people went mad. People were in trouble. So why is it so? Because today we have made our lifestyle in such a way where electricity is an integral part. We can't even think of spending a single day without electricity. So electricity, this is one of the greatest invention by physics for mankind. I mean, look at this, just by creating a voltage reference through something as simple as a battery, we can make electrons flow, and this is the entire basis of electricity. And today we have come to such a point that we cannot even think about spending a day without electricity. We can't really do. So somehow, sometimes I feel that we have taken physics for granted. We have forgot to acknowledge the contribution of this subject, which has made so much contribution to value addition of our life. I mean, let me cite another example. Transistor. It was discovered by Shockley and his team in Bell Lab in 1947 probably. And today transistors are the basic structural unit of a computer chip. And depending on the input voltage condition, this transistor can act as a switch. I mean, for some input voltage, it will be an off state, it will be in an off state. For some input voltage, it will be in an on state. And through in any computer, there are billions of tiny transistors through which information can be stored and manipulated. So there are another example, say airplanes. So flights can be possible to fly. I mean, it is possible for airplanes to fly because of the application of Bernoulli's theorem of fluid dynamics, so which is again physics. So I can go on and on during this entire time, but these are all the examples that were done many years ago. Now, if you ask me what physics is doing right now, what contribution it is making towards our life right now, so now I have a question, I have an answer. And so the first point that actually there are many ways in which I can describe the contribution of physics towards the value addition of our society. The first point that I want to mention here is that the application of physics in medical sciences.
Very nice. Yeah.
And sir, you will be pleased to know that the first thing that comes to my mind here is that cancer diagnosis and prediction. We all know that cancer the mortality rate of cancer is probably the highest in any country, rather than any other diseases. So modern physics research, so what is cancer? First let me tell that cancer is a group of disease caused by uncontrollable cell division. And for this uncontrollable cell division, sometimes a tumor is produced and it can spread and destroy the surrounding tissues. But modern physics research has created a path or as an improvement towards the diagnosis and treatment of cancer. So first let me focus on the diagnosis part. So when I'm saying diagnosis, the first thing that comes to my mind is computer tomography scanning by using X-ray, again physics. Computer tomography scanning is popularly known as CT scan, and it is used in very regularly, not only for cancer detection. Today doctors prescribe it for any diagnosis, for mainly for tumor detection. Then there is another thing which is a pure application of physics, which is the PET scan. What is PET scan? PET scan is positron emission tomography scanning. And it particularly relies on a particular type of radioactive decay where positrons, the antiparticle of electron, is emitted from a substance. And you know, sir, what happens here is that a radioactive substance is attached with a bioactive material, and then it is injected into the body of a patient. And because of that bioactive material, the radioactive isotope gets accumulated in the body of the patient, and then the positrons get emitted. And this positron, as it is an antiparticle of electron, it then gets annihilated with the surrounding electrons. And due to this process, we physicists call it pair annihilation. And as sir mentioned, the thing E is equal to mc square, we all know this relation. Because of this relation, it is an application of this pair, as mass is being destroyed, so some energy is created. And this energy is emitted from the patient's body in the form of light, which then gets detected by the imaging camera and is used to construct 3D images of the infected area. So it is a pure application of physics. Then there is MRI, magnetic resonance imaging, which also relies on a very basic fact of physics, that in presence of external magnetic field, all the magnetic atoms can realign itself. So there are lots. What
we thought as medical science concepts are actually at the base physical ideas coming from physics, and that's a great application of physics in the context of healthcare. Continue, ma'am. What other societal impact do you find?
Yes, in fact, as far as I have talked about diagnosis. Now, as far as treatment is concerned, you know, apart from surgery, one of the greatest treatment for cancer patients is radiotherapy, which is again a research outcome of curiosity-based particle physics research. I mean, what happens here is that a high energy radiation, high energy particle beam is deposited on the cancerous cells, and if the dose is right, then it can rupture the DNA in the cell nuclei. So this is again an application of physics. And now particularly now people are working towards another field, which is the low energy terahertz radiation, and people are using this radiation for early stage detection of skin cancer and particularly breast cancer. Because this terahertz radiation is nothing but light, where wavelengths lie between microwave and infrared domain. And this terahertz radiation, they have the ability to penetrate through several millimeters of a body where water content is low. Several, for example, say fatty tissues, and therefore it can be used to detect very early stage cancer, particularly skin cancer and breast cancer. And you know, sir, this terahertz radiation is quite safer compared to the X-ray radiation, because it's a non-ionizing radiation. It is less invasive, less painful. So now you can understand the impact of physics that we have on medical science. Medical science,
yes. You had talked about the telecom industry earlier, and now telecommunication field as earlier.
Yes, there are other applications as well. Let me cite one by one. Another point that I want to mention is space industry. Space industry, and around the world, the space industry has generated based on physics research. I mean, everything is related to physics there, starting from how to design the satellite, then how to calculate the trajectory in which the rocket are to be launched, then what are the methods that need to be followed to keep the satellite on track, and in right direction. So everywhere is physics. And now this satellite industry, we all know that it has revolutionized telecommunication, broadcasting, defense of many countries and network facility. So overall, this impact has increased the productivity of people around the world.
Very
so
good.
it is another very impactful.
A very simple, lucid, well documented, well illustrated exemplification of the various applications of physics in daily life, in societal use, in industry use. Thank you very much for that. That's quite an erudite talk. You have used, and people use normally, particle physics, nuclear physics, high energy physics. Now, could you, in a couple of lines each, define each of these areas and one or two more if there are, and say how are they, newer areas of research? What are the futuristic research domains in that? So, particle physics, nuclear physics, high energy physics. What other domains of physics are there?
I'm talking about all the specializations.
Yes, so if you could speak about one or two, how each one is distinctive or unique in their own way.
Each one is very much distinctive, as you will study after master degree, that you will say nuclear physics is mostly concerned about the properties of nuclear. High energy physics means which deals with the particle radiation, where the high energy means where the energy of that particle goes to from giga electron volt to tera electron volts. Then there is condensed matter physics, where mostly people deal with the properties of electrons or other subatomic particles in a dense state, where the number of particles are very high. That is, in solid state we know that. And then very recently liquid crystals are added, and we all know about LCD, liquid crystal. LCD means liquid crystal display, and the name itself is very intriguing. I mean, what is liquid crystal? This is a particular kind of material that can flow like a fluid, that is why liquid, but the molecules can orient themselves in a crystal like pattern, and that is why the name came liquid crystal. And we all know the application of liquid crystal. I mean, in our mobile phone there is liquid crystal display, in our computer monitors display, video gaming. So what happens here is that, let me just say a few minutes, a thin film of liquid crystal is produced between two glass plates, and then the glass plates are coated with transparent electrodes. And those transparent electrodes are then connected with external battery sources. Now, depending on the input voltage, the optical properties of this thin film of liquid crystal can change, and this has very much impact on our monitors, smartphones. We all know that LCD. Similarly, another thing is quantum computation. We have even 20 years back we didn't heard about even the name quantum computation. So what is quantum computation? Quantum computation, we know, I have already talked about bits, where transistors are used as bits. In quantum computation, scientists are using quantum bits or qubits, and it is depending on three basic properties of a quantum mechanical system. Like number one, there can be linear superposition of the states, which is not classically possible. Number two, there can be possibility of quantum mechanical interference. And number three is that even though two states are spatially separated, they can be entangled with each other. Now, based on these three properties, quantum computation is designed. And you will be happy to know, sir, that very recently in November 2019, Google has claimed to have achieved quantum supremacy just by performing a series of operations which just took a few seconds, which they claimed would have taken around 10,000 years by the best supercomputer of the world. So you can imagine the kind of revolution, the kind of impact it has, the potential it has. And big shot companies like Google, IBM, they are spending billions of dollars on it. So and it will change the face of quantum cryptography. So this is another specialization.
So quantum physics itself has various further specializations.
Quantum physics, no, sir, right now quantum physics is not a specialization. It is, I mean, we have advanced so far that quantum physics has become a very general formalism right now.
And within that many things are coming out
after learning quantum physics, you can go to many specialization. I mean, condensed matter physics is an application of quantum physics, nanotechnology is there, spintronics is there, quantum computation is there. One thing that I want to mention, another point, is optical fiber technology. Optical fibers are nothing but glass threads
Right.
where the core and cladding has the approximate dimension of a human hair, and it can transmit light up to a very long distance without dissipation.
Right.
And now these optical fibers are used, have brought a tremendous revolution in the field of telecommunication,
Right.
in the field of medicine, in the field of sensor making processes. I mean, some regions in mines and oil wells where human being can't go there, but optical fiber based sensors can measure lots of, can take lot of information from there. There are endoscopy, we know about endoscopy.
Yes, endoscopy,
Yeah, in endoscopy, optical fiber, doctors use optical fibers to see the inside of a patient's body.
Yeah.
So we can imagine the impact of optical fiber technology can bring. Then very recently, a group of physicists in Imperial College London, they have devised something called a chemical monitoring system, and the name of the system is DUVAS, Differential Ultraviolet Absorption Spectroscopy.
Very good. Okay.
Now this DUVAS it's a very recent invention,
yeah.
And this DUVAS has the capacity of detecting 20 chemicals. Actually they detect airborne particles, and this system has the capacity of detecting 20 chemicals within a few seconds with parts per billion accuracy, which right now no other system can do. And I have forgot to mention another very important side, which is biophysics.
Right, biophysics.
And biophysics. I mean, and the area of biophysics, it was generated by Watson, when Watson and Crick, they discovered by application of X-ray crystallography the DNA double helix structure. And you know, sir, who was Crick? Crick was a physicist by training.
Right.
So after this discovery, a new discipline is developed in which is called today molecular biology, where
Right.
physicists, chemists,
And
biologists,
life scientists
yes,
come
it's an
together.
interdisciplinary field. People are working there together to understand the basic processes of life.
Right.
So there is GPS, Global Positioning System.
Yes, GPS.
It's a navigation-based, satellites-based navigation technique, and for which accurate timekeeping is very much essential. And to keep this accurate timekeeping, two theories of physics, basic physics, are very much essential. One is relativity, another is quantum physics. And we all know, we all talk about nanotechnology. Nanotechnology, so we are living in an era of miniaturization. I mean, devices are getting smaller day by day.
Yes.
You know, sir, who is called the father of nanotechnology? It is again Richard Feynman, another world-famous theoretical physicist at Caltech. Okay. I mean, he was a Nobel laureate, but being a Nobel laureate is probably an understatement for him. His contribution is so much great towards physics. And today, if we need to understand the current carrying phenomena and related things through the small-scale devices, we must understand the behavior of subatomic particles like electron in those small scale, like nanoscale. And for this, we have to rely on quantum mechanical principle. There is no other way. So we can now impact. There are different specialization which generates from the very basic of physics, like quantum physics, classical physics. There is data science, there is non-linear dynamics, there is everything. I mean, lots of streams are there. And last, I want to mention there is another specialization can be there, which is spintronics, in which I did my PhD on that. And you know what, in basic electronics, what happens? People usually focuses on the property of an electron, which is called charge. Right. We all know that electrons have charge. But in spintronics, it is not the charge of electron, it is the spin that carries the information.
Okay.
And the idea of this spintronics was initiated by the discovery
so
of...
it's a part of nuclear physics then?
No. It's a nuclear is completely oriented in the nucleus.
Okay.
Around the nucleus.
No, you're talking of the electron, right?
Electrons.
But that's a component of the nucleus.
No, I mean electrons are outside the nucleus.
Okay.
And inside nucleus there is neutron and proton.
Proton, yes.
Yes. So when we talk about spin, I mean this idea of manipulating electron spin was first initiated by the discovery of giant magnetoresistance effect, or GMR effect, by Peter Grunberg and Albert Fath, probably in 1987, and they got awarded Nobel Prize in 2007 for that. And why GMR is so important? What is GMR? GMR is the drastic change in electrical resistance of a multi-layer formed by alternating magnetic and non-magnetic one when an external electric field is applied. And these spintronic devices offer several advantages over the conventional electronic devices like non-volatility. Non-volatility means information is retained even after the system is switched off.
Right.
Second, increased integration density. Third, decreased electrical power consumption, which is very essential today. Increased data processing, which is also very essential for a higher functioning of computers. So all these things, there are multiple disciplines which can stem from basic physics.
So much of physical principles go into
Yes.
making of technologies that we day to day use, from GPS networking to our mobile phone to our
Yes.
laptops, and for health detection, any disease detection and all that. Indeed, it's so vast, and you are so thorough with that. I would like to ask now, in this entire gamut of physics that you explained in its variety, in its variegated nature, how do you encapsulate this world of physics through the bachelor's and the master's degrees that you have at Adamas University in your department? So what differentiation you have between the bachelor's and the master's, what time duration you have, what focus areas you have, how much equipped are you in terms of infrastructure, in terms of human resources, if you could focus on that.
Yes, sir, very significant question right now. So till now I have talked about physics. And now let me introduce the programs that in our university we are offering. Right now we are offering total 4 programs. One is a BSc Honours in Physics, MSc in Physics, which is mostly the pure physics, and MSc Tech in Medical Physics and Instrumentation, and then PhD in Physics.
MSc Tech.
MSc Tech. So I'll talk about it. Let me come one by one.
One by one.
So when a student, he or she has already decided that he or she wants to pursue physics, what are the things that he or she looks forward to? I mean, number 1, the curriculum. Number 2, as you say, the human resources, the faculty strength. And number 3, another important thing for a subject like physics is the lab strength. What is the lab infrastructure? So let me come. The first thing is academic curriculum that we follow. We follow here a very updated CBCS approved curriculum where we pay our attention, or rather we emphasize on both foundations of physics and applications of physics on equal importance. We give equal importance to both of them because both are necessary. Unless you know the basics, you will never be able to apply the physics, or unless you learn something about the application, you can't really apply it in the real field. So we pay attention to both of them. And I can say that although we have structured our syllabus following CBCS, but there is something more. We have added something extra to make our syllabus something unique. Like, for example, the first part is that we have embedded here is the summer internship. During summer, we send our students to various, depending on their inclination, we send our students to various research organizations and industry, and they can get a real flavor of research work. What is the actual research that is happening around us, that is happening in different research organizations? What is the real job profile that you need to have? What is the real experience that you need to have to achieve a job in a corporate sector? So that's the thing. Next thing we have added is compulsory dissertation for all undergraduate and postgraduate programs. And this dissertation, there is no syllabus.
This is lab-based dissertation?
Yes, sir.
Practical based?
Yes, it is. Sometimes it is practical based. For theoretical research, it is computer simulation based,
right,
which is again lab-based. So, and there is a bounded syllabus for dissertation.
It's
People
organic.
can go on.
It's organic. People
yes,
can
people
take up anything.
Take up anything. They can research, and I'm proud to say that some of our students, they have done so good work in their dissertation that it has been their work is published in SCI journals,
Very
international
good.
journals.
Very good.
I mean, 4 or 5 publications are there last year from Department of Physics. So I'm really proud of it. And then another thing is, during this dissertation, students give presentation at different times, and it benefits them in twofold ways. First of all, they learn the very basics of research, that is the primary focus of us. And secondly, they learn how to present their thoughts, how to present their ideas in front of academicians, which is very important to be an established physicist, I guess.
Right.
And then we also organize very regularly several co-curricular activities like conferences, seminars, workshops, and even we didn't stop during pandemic. We organized various online workshops and webinars even in the time of this lockdown. So even in this year, in 2020, I want to mention that we had organized a 2-day national conference, NCFMP 2020, in collaboration with IOP Science UK. And starting from TIFR Mumbai to ISCS Kolkata to Bosch Institute, almost 8 speakers came. They shared their knowledge, and across the India, from various institutes and various states, people came, researchers, scholars and students came. They shared their idea in poster presentation, in talks, and 30 papers, 30 best papers selected by the technical program committee, that will be published very soon in IOP Science Journal of Physics conference series. And we are also planning to have, we could have done it earlier, but during this pandemic we couldn't do it. We are also planning to have another conference, which is AMPHI 2020, that it advances in medical physics and healthcare engineering. Right. It's a very need of the art topic, and in this conference we have got technical collaboration from Springer, from Elsevier, so highly reputed international publishing houses. So it is there.
So how is your BSc and MSc, how do you evolve? BSc coverage of the course, the curriculum, yes, and MSc how specialized focus areas, yes, and you have come out with an MSc Tech, as you said just now. Yes. If you could differentiate, yes, between this.
So in BSc we focus on the basics like mechanics, quantum mechanics, electrostatics, optics, people are there. And as per CBCS, in 3rd year we introduced DSC papers like discipline specific electives, and as per UGC curriculum there are already 14 kind of specialization from which students can choose. And now one thing I must mention, that it is not possible for every college or university to offer at least 14 specialization, because you need to have similar strength of faculty members. Either if you don't have faculty members who has their own specialization in different fields, you cannot offer them. So right now I am proud that Department of Physics has that strength, and we can offer this kind of specialization. In MSc we have specialization like, as I said, high energy physics, condensed matter physics, biomedical instrumentation and applied electronics. And we are also planning to incorporate nonlinear dynamics if the students wants to take it up, because data science future is huge. And then MSc Tech. MSc Tech, I want to talk about it separately, because MSc Tech in medical physics, it's a completely different program domain, yeah, than the BSc Physics or BSc, though definitely even from MSc Physics. It is a completely interdisciplinary program, right, and it's a concoction of medical science and engineering and as physics. Well, yeah. Yes, and it's a interdisciplinary stream in true sense, because we have papers like management, we have papers like microprocessor, we have papers like anatomy and physiology, we have papers like nuclear medicine. So you can understand we need to take help from different other schools, right, from engineering, from School of Life Science and Biotechnology, from School of Management. So it is a truly interdisciplinary stream, and people who are and there is a scope of research.
I don't think this particular subject is there in too many
no, only in Jadavpur University, okay, there is a PG diploma program, okay, and in Calcutta University there is one program where the seats are very limited. It is 10 seats.
Master degree.
Okay. And now we have
across India also it won't be there. So
and but right now, sir, the job market is very high for this particular subject, because you know, the government of West Bengal, Moumita Dey, she has announced that for each hospital and each diagnostic center, one medical physicist is compulsory. Okay. So the position is there, the job is there, but the people are not there. So right now the demand is very high, and not only as a radiation safety officer or as a medical physicist, this particular subject has a very open forum for research, open area for research. I mean, one of our students, sir, Devoshmita, she got chance in Mendel University, Czech Republic, and she was doing research in the medical physics. So this field is open for study, this field is open for research, job. So it's a very vibrant field, I think, right now. And actually one thing I mentioned, that to be a medical physicist or a radiation safety officer, we need to have AERB accreditation, and we are right now we are working on it. And very soon I hope we will be able to get it. And till then, if the students who passes out this program, if he or she does an internship program with any ARB accredited institute, he or she is automatically able to sit for the exams of medical physics and radiation safety officer. So this is another program which is totally different from MSc Physics and which is a particular object towards being radiation safety officer or medical physicist or other research area like biomedical engineering.
So
and
would you prefer the students coming for the 5 years learning, 3 years of BSc and 2 years of masters, and masters in any of these specialized areas that you have said?
Yes, yes,
it so it's ideally
wonderful.
five
it is
years.
Ideally it is 5. So.
And normally, I mean, anyone can go for any competitive exams after graduation is known. But after 5 years of focused study on physics, what are the career opportunities that youngsters have?
Yes, this is another question, a very important question. A student who is usually studies physics usually as a passion, as a passionate thing, I have seen in my experience most students want to pursue academics to the higher level, and they go for research. They go for there is an option for research. There is a option for scientific officers in different organizations like VCC, BARC, DRDO, ISRO. Now, if your research profile is too good and you have done a great research in your life, then the options for becoming faculty member in reputed research organizations and or being a scientist in centers like DRDO and ISRO is open for you. Then there are obviously academic jobs are there. You can go in this from school to college to university. This is there. And another thing is, initially we have a misconception. We have a misconception that IT industry is only tech engineers. No, this is not right. Today, IT industries prefer. In fact, we had a few days back, we had a discussion with our director of CDC, Career Development Cell, and he said that now IT industries are preferring students of physics background, students with mathematics background.
Yeah, science background.
Yes, yes. And
even IT industry wants content developers also.
Yes, yes.
Various other backgrounds.
Yes, so there is option. There is biomedical research option in companies like Siemens and Philips and etc. GE Electricals. GE Healthcare, then there is option for data scientist, data analytics, then there is option for any electronic R&D sector, any companies. So the job market is high. So you just need to learn first the subject very carefully.
Very well,
Yes, because physics is a subject of passion. Right. If you have the passion, if you study the subject, if you know it from the depth, you will be able to get a job.
What is the research profile currently of the department? What sort of PhDs are being done? What sort of themes are being researched, if you could speak on that?
Yes, in our department right now we have total 12 faculty members. All of them are PhD. Some of them have experience, postdoctoral research experience from several other research organizations and even from abroad. And we have a very good research profile. As I said, physics is a fundamental subject and it has various multiple disciplines like high energy physics, condensed matter physics, biomedical instrumentation, plasma physics, nonlinear dynamics, laser and optical fiber, material science. So we are fortunate that in our department we have people who are specialized in those different areas and they are pursuing research. In fact, sir, you will be happy to know that last year in our department have published total 12 SCI journals, international journals, and 5 Scopus Index conference proceedings. So this is the data for just for last academic session. So yeah, we are doing very good research. One of our faculty member, Dr. Tamal Kumar Mukherjee, he just completed last year his DST project as a Ramanujam fellow.
Great.
It was worth around 35 lakhs.
Great.
Then we have Dr. Moumita Mukherjee, who is currently pursuing various industry projects from various companies, and it's worth around 23 lakhs. So people are doing research, people are getting projects, we are publishing our works. So I think in our department current scenario, the research profile is really vibrant.
If I have to ask you, if any youngster who comes to study in Adamus University Department of Physics, whether at BSc level or at MSc level, what 3 or 4 things you will say are standout program aspects or USPs of the department? One, I get you have 12 faculty members, all of them PhD holders.
Excellent
and some
research.
of them are postdoctoral also research
Yes.
holding as well. So that's point 1. if you could tell two
Yes,
things.
the number one, as sir said, excellent experienced faculty fraternity and good number of faculty profiles. Number two, a very well updated syllabus. Number three, state of the art lab. Now I'll talk about the labs later. And number four, our co-curricular activities, because along with academics, along with classroom teaching, we also emphasize on these co-curricular activities which develop the students for their future research, be it job. It creates that mind, because creating the mind for physics is very essential. And it creates that mind. So these are the four features that I will say stands out our department in Adams University.
You wanted to say something on the infrastructure.
Yes, sir. I want to say that our departmental lab is very strong, and it is not my statement actually, sir. In 2017, when UGC team member came here to visit, and standing in our physics lab, that UGC person, he said that the standard of this lab is at par with any central university in India, or even better than that. So, and from then we have still procured many instruments from then, and we have tried to develop our lab as much as possible. So, apart from regular engineering physics, BSc LLB, BSc physics, MSc physics lab, we have some special kind of labs like thin film vacuum coating unit, and the instrument is very costly. We have that lab, we have that facility to coat a thin film, to prepare a thin film. And then we have ellipsometer, we have laser and fiber optics lab, we have medical physics lab. So various specialized labs are there. And not only these instrumental labs, I want to say that people who are interested in theoretical physics, right now computer simulation, you can't do anything without computer simulation. So apart from this, Python and C and Java, this Fortran 90, all these are common features. This is taught everywhere else. But we have specialized softwares like MATLAB, like Mathematica, like COMSOL, and we have a very high-end computational facility which is not common everywhere. So this lab facility, I think it is state-of-the-art lab, and it is a very good facility for the students, and students who are interested can visit here. They can visit our virtual lab facility, which is given in our website also.
Right. That's another important point, virtual
Yes.
lab. This pandemic has shaken the conscience and also the physical world, mental health, everything of the people around the world. How are physicists contributing to mitigating the risk and the crisis of pandemic and ways and means of coming out of it? How are physicists contributing to that?
Yes, sir. Physicists are also trying their level best in their own capacity to contribute towards the society in this pandemic scenario. For example, we know that RT-PCR, reverse transcriptase polymerase chain reaction, RT-PCR is now considered to be the golden standard of measuring COVID-19 patients, COVID positive patients. But there are alternate ways. For example, physicists are trying to show that, medical physicists, they are trying to show that by looking into the chest CT pattern, chest CT scanning report, you can detect COVID-19 without having even RT-PCR. Like there are features like peripheral multifocal, which is called ground glass opacity patterns. I mean, something is there like this. There is something called crazy pavings. I mean, with this characteristic features, you can detect whether a patient is COVID positive or not. I think this detection technique, physicists are helping towards this detection technique. Then I read somewhere that the first protein structure of this COVID-19, the spikes and everything, the first structure which was reported to Protein Data Bank, it was done by a group of physicists of Shanghai. And then there is some other statistical physicists who are taking care of all the data of COVID-19. They are collecting all the data, and they are trying to simulate those data with the help of those data, and they are trying to predict what will be the temporal and spatial distributions. So all kind of predictions are there. People are publishing papers. So yes, they are all trying. I know that all contributions will not impact at equal level. It is not possible in any case, but people are trying. People are trying from their level best.
Great. That's also an important role that the physicists are doing today. Professor Moumita, you have actually covered a large number of aspects, and it was beyond my expectation. Large number of specialization areas of physics. an head of the department is expected to know the fundamentals of every specialization in that domain, should be and can be expert in one. In your case, it's spintronics. And in your case, you have really exhibited knowledge and spread of knowledge, I might say, on all domains, on all aspects and all specializations of physics. I'm really happy to note that that entire department has a faculty pool which is completely PhD and many with postdoctoral research as well. And you have a virtual lab available in our website, Adamas University website, a virtual image of the entire lab that you have got. And the infrastructure that you have is of a national level. Indeed, it is heartening to note that Scopus indexed and higher level journals are carrying articles of our research outcomes of our students also, along with faculty members. This is a fabulous thing to happen. I do not think too many universities can claim that students write on ACA and Scopus index journals on their research findings, which they do at dissertation level. And the way and the ease with which you have explained the differentiation and the variegated quantum physics, plasma physics, nuclear physics, particle physics, high energy physics, and many other, dynamics, and the applications in health sector, applications in telecommunication, applications in various domains of life. It's a fabulous thing to really understand the role of physics as a discipline of learning and as an impactful domain in societal life. I really also appreciate the amount of co-curricular activities, or rather research-based outcome activities, if I can say, in the form of seminars, conferences, webinars, and Scopus indexed articles. It's fabulous to note that. Really appreciate the good work that is being done in the physics department of the School of Basic and Applied Sciences at Adamas University. Would look forward to someone coming out with far more, as you had a Ramanujam Fellow, maybe a Bhatnagar Award, and maybe sometimes international recognition of the work that you are doing at the highest level of physics. Thank you very much, Professor Moumita Dey, for your in-depth discussion on the world of physics and its application. Thank you, everyone. With this, we bring this session to an end, and we are happy to have presented to you in 50 minutes the world of physics, and I hope that you would listen to it and re-listen to it to understand the dynamics better. And thanks to Professor Moumita Dey for facilitating that.
With a 2% share of the India's GDP, the media industry is growing faster than India's GDP. And with the world's largest number of films and television channels, it is the national informer and entertainer. With more than 1,000 films a year, cinema is our soft power. News, entertainment, brand communication, we lead Asia in all. And a multi-skilled multimedia talent is being trained in the Adamas School of Media and Communication. As India aims for $5 trillion economy, the nation needs a large pool of trained economists and commerce graduates, focusing on taxation, macro and microeconomics, etc. Adamas School of Economics and Commerce is in the mission preparing finance and economics professional to lead this journey with value-added modules on the stock market and big data. Biosciences and technological developments based on biology, including entrepreneurship in this sector, are on the rise in India. We are home to many developments in all forms of biotechnological products with applications in food, nutrition, healthcare, packaging, etc. The unique BTech and BSc programs in Adamas School of Biosciences and Biotechnology are path-breaking academic innovation in this sector. Welcome to the world of biotechnology. It is important to be on the right side of the law, and even more important to ensure justice for all. The Adamas School of Law and Justice firmly believes in this dictum. With moot courts, national and international seminars, debates and initiatives of various type, the law school offers integrated courses with BBA, BCom and BA as well, with different focus areas. With a 24-hour work culture, Adama School of Management prepares professionals for marketing, human resources, finance, supply chain management, and pharmaceutical management for the new Indian economy targeting $5 trillion annually. Close association with several top corporate houses and intellectual talent in the classroom, the school is proud to have one of the highest placement records in East and the Northeast India. Pharmaceutical technology is on the rise in India in particular and Asia in general. And newer research in medicine is modernizing the sector immensely. We in India have the fastest growing pharma sector in the developing world today. Adama School of Pharmaceutical Technology, with its superb and detailed laboratory facilities, has one of the best pharma schools in the nation waiting to welcome you.
ভালো রোজগার, কাজের স্বীকৃতি, স্বপ্নের চাকরি, এগুলোর জন্য কি শুধুই কঠোর পরিশ্রম যথেষ্ট? না, এটা পড়াশোনা এবং প্রফেশনাল ট্রেনিং এর একটা কম্বিনেশন। তাই যে এমন একটি কলেজ বা ইউনিভার্সিটি যেটা এই দুটোরই গ্যারান্টি দেয়, যেমন অ্যাডামাস ইউনিভার্সিটি। এখানে ছাত্ররা শুধু পরীক্ষায় দারুণ নম্বরই নয়, সঙ্গে পায় দুর্দান্ত প্লেসমেন্ট এবং কর্মজীবনের প্রয়োজনীয় দক্ষতা। তাই আজই নিজেকে রেজিস্টার করো অ্যাডামাস ইউনিভার্সিটির অ্যাডমিশন টেস্টে আর এগিয়ে যাও একটা উজ্জ্বল ভবিষ্যতের দিকে।